Well, it's been quite a while since I've been out in the shop, and gonna have a little preview of what's been going on here. It has been ridiculous cold for like 2 weeks, polar vortex, and as a result I really wasn't too enthusiastic about coming out to a shop when it was -10. I do have heat out here, but there's a couple problems with that. One of them is the heater heats up the air real good, but it doesn't heat up the machinery worth a damn. So everything's really cold and stiff, and just not, I don't really like running my machinery when it's like that. It kind of beats on it. The other problem is condensation, which is the subject of this video. And living here in the Northeast, we have a situation around this time of the year where we'll have some really cold days, and that'll soak the machinery down to like really low temps, and then we'll have a day where the fog rolls in and it's 50. And I've come out to this shop when that's happened, and it looks like somebody has sprayed a garden hose on all the machinery, just because of the condensation. So I've been thinking about this for a long time. I usually, when that happens, I come out here and I start painting all the machinery with oil, and it's just not a fun thing when it happens. And it happens, like I say, around this time of the year. So I spent my polar vortex time inside writing software and designing some hardware that will hopefully, well, actually I know it does take care of the problem. I'm going to show you guys what I've done. This here, this box right here has an Arduino microcontroller in it, and a couple solid-state relays, power supply, and all kinds of goodies like that. And I have let me see if I can give you a shot of this. On the base casting of the lathe, I've attached a couple of silicone heaters right here. Each one of these is a 100-watt heater. It runs off 110. This right here is a little block I had to make that attaches a temperature sensor to the lathe bed. And what this thing does is, using this sensor right here, which is a temperature and dew point, or temperature and relative humidity sensor, it calculates a dew point. And let me tell you, it's damn close to real. And when the Arduino is looking at the chassis temperature, and when the dew point, it tries to maintain the chassis temperature at 5 degrees Fahrenheit above the dew point, which theoretically will guarantee that it will never have a condensation problem. Well, it actually works. I had it out here. I installed it a couple days ago, and we had the same thing. It was really cold for a couple of days, and then the fog rolled in, and this lathe stayed dry. This mill did not, which confirms that those conditions did exist at the time. So, fortunately for me, I designed this thing for 2 machines. I've only got one of them hooked up now because I wanted to compare what the with and without were, and I'm quite happy with what happened. I'll just give you a demonstration here. Let me see if I can do this. If I breathe on the sensor, I'll raise the relative humidity in the area, and you'll see a red light go on, which will indicate that it's turned the heater on to the lathe. Takes a few seconds. There it goes. So it's saying, hey, I'm in a condensing atmosphere right now. The relative humidity is high, and I need to heat up this base casting to keep this thing from doing it. Now, in real life, these slews are nowhere near as fast as what I just did. You know, it takes quite a while for the relative humidity to go up and down. You know, it goes over the course of hours. So, you know, the heaters really aren't running all that much. You know, I'm going to hook a kilowatt meter up to this thing and just monitor it over time to see what happens. But, you know, from what I've seen with this light going on and off, these heaters aren't really running all that much. It just keeps the base casting slightly warmer than the dew point, which doesn't take much energy at all. You know, I want the thing to be able to heat up the casting good, so I put 200 watts of heat into it, but it's not on for all that long. You know, this here, I'm going to do this today, and hopefully this thing will just live out here and cycle on and off and keep my machinery from rusting up. You know, I figure, you know, I'm heating up the base casting. It's going to, you know, migrate through the ways into all these other parts as well. So, you know, basically, you know, from the chip pan up is going to be eventually at this 5 degrees Fahrenheit above, you know, the dew point. So anyway, that's a story. I'll show you some parts here, I guess. These are the heaters. Got them from McMaster car. Cost like 20 bucks a piece. You have pressure sensitive adhesive on the back, and pigtails, which you got to wire up to a controller. You cannot connect these directly to 110 AC. You got to have a controller, or they'll just nuke. They do get pretty hot. It's 100 watts. I don't know if you can see that. And the Arduino stuff, you know, I didn't really record too much of that. I didn't think you'd be interested in watching me write code or solder. But, you know, suffice to say, all it is just a little Arduino controller, a couple solid-state relays, these temperature sensors that bolt to the machine, as well as the this little, you know, humidity sensor thing. They're all digital. There's no analog. It's all serial communications up to the thing, so there's no worries about machinery noise getting into it or anything like that. And it just sits there and says, you know, every 2 seconds it pulls this little sensor and says, give me the temperature of the air and give me the relative humidity. And it does a little math on it to compute the dew point. There's a well-known formula for doing that. And then it just reads the machine temp and says, hey, is it 5 degrees above that? And if it isn't, it turns the heater on, and if it is, it shuts it off. So that's about it. That's what we've been working on here. You know, finally we got a day out here where things are starting to melt. It's like 50 today. It was like 30 for the last couple of days, and then before that it was like 10. So we're out in the shop here. I'm going to wire this thing up, get it all done, get it, you know, clean up some of the haywire mess that's going on with it, because now I'm done testing it and I'm just going to put it in for good. And you know, the next project we'll be working on is I've been working on an Arduino based TIG pulsar, because I got a Synchrowave 180. It's too old to have a pulsar on it. So I'm going to put one on there. I'm not going to have to modify anything. I'm just going to put it between the pedal and the welder. You know, get a couple of the same connectors, a male and a female, just put it between them. And, you know, that way it doesn't change anything, and it gives me some extra functionality for TIG welding. Okay, that's about it for now. Thanks for watching. Okay, well, we got a little epilogue here. Finished wiring this up, so figured I'd give you a look inside. A couple solid state relays, switching power supply. It's like 12 volts to drive the Arduino and the sensors. Here's the nano. Here's the sensor for the ambient. These two wires, the white ones, go over to the temperature sensors on the machines. These two pairs of wires go to the heaters. There's the AC input. Notice my fuses. Would not trust this thing without fuses because it's going to run 24/7 unattended. Okay, well, let's see. I don't know if you can see that, but that's one of the heaters. The other one you can't see because it's under the DRO scale, but it's right in the same place. And the temperature sensor block I mounted right there. And here's the sensor. So that should do it. I'm going to power this thing up and hopefully I'll be able to edit this video without having to take a trip to the burn ward. Bye.